So now moving on to our topic, there is there are two important things you should know. One is symmetry operation. First, I told about symmetry. Symmetry is just similarity, and there is a symmetry operation and symmetry elements. We have to, you should have a clear knowledge about what a symmetry operation is and a symmetry element is. Let's first look on to what a symmetry operation is. Symmetry operation, as the definition goes, a well-defined non-translational movement of an object that produces a new orientation that is indistinguishable from the original object. So what is a symmetry operation? It's just a movement of an object. And how should that movement be? It should be well-defined movement and non-translational. Non-translation means we cannot change the whole object from one place to another. There should be at least one point which will remain at the same place. That is why it's called non-translational. ഒരു ഒബ്ജക്റ്റ് എടുത്ത് അതിലൊരു ട്രാൻസ്ലേഷൻ അല്ല അതിനകത്ത് ഒരു മൂവ്മെന്റ് നടത്തുമ്പോൾ ആ ഒബ്ജക്റ്റിനെ നമുക്ക് കംപ്ലീറ്റ് ആയിട്ട് ഒരു പ്ലേസിൽ നിന്ന് വേറൊരു പ്ലേസിലേക്ക് കൊണ്ടുപോകാൻ പറ്റില്ല. അതിനകത്തുള്ള ഒരു പോയിന്റ് എങ്കിലും അവിടെ തന്നെ ഫിക്സ്ഡ് ആയിരിക്കും. That's why it is called non-translational. And what happens after the movement is, after the movement, the object should look the same as it looked before. നേരത്തെ എങ്ങനെയായിരുന്നു ആ ഒബ്ജക്റ്റ് അതുപോലെ തന്നെ ആയിരിക്കണം അതിനകത്ത് ഒരു മൂവ്മെന്റ് നടത്തി കഴിയുമ്പോൾ. അതാണ് തന്നെ നോൺ ട്രാൻസ്ലേഷൻ മൂവ്മെന്റ് ഓഫ് എൻ ഒബ്ജക്ട് ദാറ്റ് പ്രൊഡ്യൂസ് എ ന്യൂ ഓറിയന്റേഷൻ. ഒരു പുതിയൊരു ഓറിയന്റേഷൻ ആണ്, ബട്ട് ഇറ്റ് ഈസ് ഇൻഡിസ്റ്റിങ്വിഷബിൾ ഫ്രം ദി ഒറിജിനൽ ഓബ്ജക്ട്. ആ ഒറിജിനൽ ഒബ്ജക്റ്റിൽ നിന്ന് പുതിയ ആ മൂവ്മെന്റ് കഴിഞ്ഞിട്ടുള്ള പുതിയൊരു ഓറിയന്റേഷൻ എന്ന് പറയുന്നത് നമുക്ക് ഒരു വ്യത്യാസവും തോന്നാൻ പാടില്ല. ദാറ്റ് ഇസ് വാട്ട് ഇസ് മെൻ ബൈ ഇൻഡിസ്റ്റിങ്വിഷബിൾ. ഡിസ്റ്റിങ്വിഷ് ചെയ്യാൻ പറ്റാത്ത രീതിയിലായിരിക്കണം പുതിയ ഓറിയന്റേഷൻ. And next we come to symmetry element. Symmetry element is, it can be either a point, or a point ആവാം, line, it can be a line or a plane, അല്ലെങ്കിൽ ഒരു plane ആവാം, about which the symmetry operation is performed. ഈ പറയുന്ന symmetry operations ഏതെങ്കിലും പെർഫോം ചെയ്യുന്നത് ഒരു പോയിന്റിലൂടെ ആയിരിക്കാം, അല്ലെങ്കിൽ ഒരു ലൈനിലൂടെ ആയിരിക്കാം, അല്ലെങ്കിൽ ഒരു പ്ലെയിനിലൂടെ ആയിരിക്കാം. അതാണ് a point, line or plane about which the symmetry operation is performed. That is called a symmetry element. So symmetry elements are mainly a plane, a line or a point. So now here you can see a triangle. There are two triangles. As we see, I don't think there is any difference between the two triangles. They are just placed one to the left and one to the right. But there is one symmetry operation I have performed on this triangle. This is the first triangle, and you can see that if I pass a line the way it is shown in the figure from the upper vertex to the middle of the opposite side. ഈ ഓപ്പോസിറ്റ് സൈഡിന്റെ മിഡിലൂടെ പാസ് ചെയ്ത് പോകുന്ന ഇങ്ങനെ ഒരു ലൈൻ. If I pass a line in such a way and I rotate this triangle. I rotate this triangle through 180 degree. I'm rotating this triangle through 180 degree, and that time it will give the same appearance. And this line is called line of symmetry. And see the rotation. Rotation is through 180 degree. I'm rotating this triangle through 180 degree, and I'll get a similar triangle. There is no difference. So this line about which I have rotated the triangle, that line is called line of symmetry. And what is the operation I have performed? I have rotated the triangle. ആ ട്രയാങ്കിൾ ഞാൻ റൊട്ടേറ്റ് ചെയ്യുകയാണ് ചെയ്യുന്നത്. അതിനകത്ത് ഏത് പോയിന്റ് ആണ് അവിടെ ഫിക്സ്ഡ് ആയിട്ടിരിക്കുന്നത്, ഈ ലൈൻ പാസ് ചെയ്ത് പോകുന്ന അത്രയും പോയിന്റ്സ് അവിടെ ഫിക്സ്ഡ് ആയിട്ടിരിക്കും. ഫിക്സ് ചെയ്ത് വെച്ചിട്ടാണ് ഈ ട്രയാങ്കിളിനെ റൊട്ടേറ്റ് ചെയ്യുക അല്ലെങ്കിൽ ഫ്ലിപ്പ് ചെയ്യുക. Okay, rotate ചെയ്യുമ്പോഴത്തേക്കും നമുക്ക് സിമിലർ ആയിട്ടുള്ളൊരു അപ്പിയറൻസ് ആയിരിക്കും കിട്ടുന്നത്. അതിലെ ഈ ലൈൻ എന്ന് പറയുന്നതാണ് നമ്മുടെ ലൈൻ ഓഫ് സിമെട്രി. അതാണ് സിമെട്രി എലമെന്റ്. നമ്മൾ പെർഫോം ചെയ്ത ഓപ്പറേഷൻ എന്താണ്? ഇറ്റ് ഈസ് റൊട്ടേഷൻ. ആൻഡ് ദാറ്റ് റൊട്ടേഷൻ ഇസ് കോൾഡ് സിമെട്രി ഓപ്പറേഷൻ. Okay, this is one symmetry element. We have gone through one symmetry element, that is line of symmetry. I hope it's clear for you all. Now let's move on to the next element. Next element is reflection. So the next element is a plane of symmetry. This plane here, this plane is the plane of symmetry. I have taken a water molecule. Okay. This water molecule has oxygen in the middle and two hydrogens on two sides. And what difference is there in this water molecule and the water molecule on the right hand side? The only difference is here, you know, both the hydrogens are same. There is no difference. But here, to identify the hydrogens, we have given one as a red color and the other with a blue color. And what has happened here? Here on the right hand side we have the blue color H or blue colored hydrogen, and here we have on the left hand side. Okay, so that means the image on the right hand side, this water molecule is a mirror image of the one on the left hand side. Okay, and where should we place the mirror? The mirror should be placed on this hydrogen. On this oxygen. When we place the mirror on this oxygen, the reflection of the hydrogen on the right hand side will go to the left hand side, and the reflection of the hydrogen on the left hand side will go to the right hand side. So here we have oxygen in the middle with hydrogen gone to the left hand side and the red hydrogen gone to the right hand side. So what have we done? What have we done here? Actually, we have reflected through a mirror. And this reflection is called the operation or symmetry operation. And this reflection we have done through a mirror plane. Okay, and this plane is called the element of symmetry. So here we have this plane as the element of symmetry, and the operation we have performed is reflection, and the reflection is the symmetry operation. I hope this is clear for you. Let's move on to the next symmetry element and new symmetry operation. Next symmetry element is inversion center or center of inversion. Let's see the definition. If a line drawn through a point in a molecule and extended in both directions encounters equivalent point in either, the point through which the line is drawn is called an inversion center. You can look at the molecule. Here there is an orange color. This molecule is actually SF6. So with sulfur in the middle, we have its octahedral in shape. That is, we have 6 fluorines surrounding the sulfur atom. You already know the structure. So considering this as the sulfur, we have 1 fluorine above, 1 below, 1 to the back side, 1 to the front, 1 to the left, and 1 to the right. So taking this as the center point, if I move a particular distance up, I meet a fluorine. If I come back through the same line and if I extend that line in the opposite direction, I'll meet another fluorine. And what's the peculiarity? I have traveled similar distances. I have traveled similar distances in opposite direction. I have traveled up to the fluorine 1 and down to the fluorine 6. Coming back to the center, if I go back a particular distance to fluorine 2, and if I come forward, I come forward to fluorine fluorine 4, and that's also at equal and opposite distance. And similarly, we have, if I move to the left a particular distance, I meet a fluorine at a particular distance, that is fluorine 5, and coming back through the same line and going in the opposite direction at an equal distance, I will find another fluorine on the opposite side. So if a line is drawn through a point and that line meets two different points, 2 points in opposite directions, equal and opposite direction, we call that point as center of inversion. We are starting with from the center. If we draw a line through that center, and if that line meets two different points in both directions, if the line meets 2 points at opposite direction at equal distance, then that point is called center of inversion. Sorry, I haven't given the definition for line of symmetry and plane of symmetry. Uh, Please note down, line of symmetry is a line drawn through the object about which, when the object is rotated, gives similar appearance, or it's an imaginary line passing through an object about which, when the object is rotated, gives similar appearance. That's the definition for line of symmetry. And for plane of symmetry, plane of symmetry is an imaginary plane passing through the molecule which divides the molecule into two equal halves. I shall repeat. The plane of symmetry is an imaginary plane passing through the molecule which divides the molecule into two equal halves. Similarly, the definition for in center of inversion is a line drawn through a point in a molecule and extended in both directions meets equivalent points in either means in both directions. The point through which the line is drawn is called the inversion center. Okay, please revise these well so that I can continue with the next class. I shall stop here, and I want you to do some work. I want you to find. I have actually collected some pictures here. I want you to find out some more pictures which looks or in which there is symmetry, in which you can find symmetry, and try to find out what type of symmetry element it has. Is it a line of symmetry, or if it is a point of symmetry, or if it is a plane of symmetry. I hope you will we can take this as an assignment, and please submit this before Sunday. Thank you.